For this video, I'm going to solve for x on the interval between 0 and 2 pi. And I'm going to do that for trig functions that have something inside of the function that is not x by itself. So I might have 2x inside, or I might have x over 2 inside. So something multiplied by x, or something, or x divided by something. And what I need to do for these problems is I need to keep in mind that there was an interval given to me, and that interval is for x. So my answer, whatever x is, should be in between 0 and 2 pi, where 2 pi isn't included but 0 is. And what I'm going to do when I have a trig function, or a trig equation, I'm going to isolate the trig function, get it by itself. So first thing I'm going to do is add 3 on both sides to get 4 sine squared of 2x is equal to 3. Then I'm going to divide both sides by 4 so that I get sine squared of 2x is equal to 3/4. And then from there, I'm going to take the square root of both sides because I want to get one trig function by itself. And so I'll have sine of 2x is equal to the square root, or plus or minus the square root of 3 over the square root of 4, which is 2. I don't want this inside when I'm making my visual for what angles could make this statement true. So I'm going to let 2x be equal to some other variable. I'm going to say theta, and then I'm going to make a visual for theta. So I'm going to make a visual for the equation sine of theta is equal to plus or minus the square root of 3 over 2. And then, excuse me, I have a cold. And then I'm going to make my visual for theta. I know because I have plus or minus, I'm going to have a terminal side in each one of these quadrants. So it's when this is when y is plus or minus the square root of 3 over 2. And that's going to be true in every quadrant. So y is positive square root of 3 over 2 in those two quadrants, and it's negative square root of 3 over 2 in these two quadrants. So this is going to be the point 1/2 comma square root of 3 over 2. This is going to be the point negative 1/2 comma square root of 3 over 2. This is going to be negative 1/2 negative square root of 3 over 2. And this is going to be the point positive 1/2 and negative square root of 3 over 2. All of these terminal sides have a reference angle of pi over 3 since it starts with 1/2. So this first angle here is going to be pi over 3. This second angle here is 2 pi over 3. This third angle here is going to be 4 pi over 3. And this angle here is going to be 5 pi over 3. And then from there, I'm going to I have to think about the interval for what theta will be, because I made a visual for a different variable that I created. So I said theta was equal to 2x, and I want to know what is the interval for 2x. So I start with the interval that was given to me. This is the interval that was given to me for x, and I want to know for 2x. Well, to go from x to 2x, I multiply by 2. So I'm going to do that for all of the parts of this inequality. So 0 times 2 gives me 0, and 2 pi times 2 gives me 4 pi. And so I have that 2x, or theta, is going to be in between 0 and 4 pi. So for this visual that I created for a different variable, theta, I need to include 2 circles. So not just going around the circle one time, which is 2 pi, but going around 2 times, which is 4 pi. So these angles that I've gotten are from 0 to 2 pi, and now I need to know all the angles from 2 pi to 4 pi. And in order to find those, they're going to have the same terminal sides as these ones here. They're just going to be the angles that I have from 0 to 2 pi plus another 2 pi. So I'll have another angle in quadrant 1 that'll be pi over 3 plus 2 pi, or plus 6 pi over 3, which gives me 7 pi over 3. So I have 7 pi over 3 is one of my angles, and pi over 3 is one of my angles in the first quadrant. This one's from 0 to 2 pi, and this one is from 2 pi to 4 pi. Okay, I shouldn't have written that much. I don't think I'll be able to, cool. For the second quadrant, I'll have 2 pi over 3, and another angle that I'll have is 2 pi over 3 plus 6 pi over 3, which is 8 pi over 3. And then for quadrant 3, I'll have 4 pi over 3 plus 6 pi over 3, which is 10 pi over 3. So I'll have these two angles, and then for the fourth quadrant, 5 pi over 3 plus 6 pi over 3, which is 11 pi over 3, will be my second angle. So I should have 8 angles total. I know that theta is equal to pi over 3. Theta is equal to 2 pi over 3, but theta I let be equal to 2x, and I need to solve for what x is. So I'm going to just do the first one. 2x is equal to pi over 3, because theta is equal to pi over 3 from here. And then to solve for what x would be, I need to divide both sides by 2. So I'm going to end up with x is equal to pi over 6. That's my first answer. All of my answers are going to have the same numerator and just 6 in the denominator. So I'm going to go in order from lowest to greatest. So I start at pi over 3, took care of that one. Then I'm going to do 2 pi over 3, so I actually have 2 pi over 6, which simplifies down to pi over 3. And then I'll have 4 pi over 3, so 4 pi over 6, which is going to simplify down to 2 pi over 3. And then I'll go to 5 pi over 3, which is going to be 5 pi over 6. And then I'll be at 7 pi over 3, which is going to be 7 pi over 6 actually. And then 8 pi over 6, which is 4 pi over 3. And then 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6, which I can't simplify. So these are my 8 answers. And they should all fit in between 0 and 2 pi, because these are my answers for x. 11 pi over 6 is less than 2 pi. So this works. I did all of them in order from least to greatest. For 18, notice that I have twice as many answers as I would have had if this was just x by itself inside. For number 18, I have 2 cosine of x over 2 plus the square root of 2 equals 0. I'm going to isolate the trig function, so I'm going to subtract square root of 2 on both sides, and I'll get 2 cosine of x over 2 is equal to negative square root of 2. I'm going to divide both sides by 2, and I'll get cosine of x over 2 is equal to negative square root of 2 over 2. And then I am going to let theta be equal to x over 2, and I'm going to rewrite this as cosine of theta is equal to negative square root of 2 over 2. I'm going to make a visual for what theta will be. I want the x values. So I want the x values that are negative square root of 2 over 2 on the unit circle. And I know that x is negative in the second quadrant and the third quadrant. And I have the point here. This is negative square root of 2 over 2, comma square root of 2 over 2. And this point here is negative square root of 2 over 2, comma negative square root of 2 over 2. This angle here is going to be, I know they have a reference angle of pi over 4, so this angle up here is going to be 3 pi over 4, and then this reference angle here is going to be 5 pi over 4. And so I have these two answers. And then don't forget to look at what your interval is going to be for the new variable that you created, because you used a single variable and put that inside of cosine. And you need to know what the interval for that is. So I know x is in between 0 and 2 pi. So x divided by 2 is going to be in between 0 and pi. Which means theta is going to be in between 0 and pi, which means I'm only including angles from here to here, which means I am not including this angle here, and I'm going to cross it out. And I'm just going to be left with this answer here. So I have theta is equal to 3 pi over 4, but theta I know in terms of x is x over 2, so I have x over 2 is equal to 3 pi over 4. I'm going to multiply both sides by 2, and I'm going to get x is equal to 6 pi over 4, or x is equal to 3 pi over 2. And this should be in between 0 and 2 pi, and it is. And so I noticed that for this first problem, 17, I had 2x inside instead of just x by itself, and I had twice as many answers as I would have had if x was by itself. For the second answer, for number 18, I had x divided by 2 inside, and then I would have had 2 answers, but now I only have 1 answer, so I have half the answers.